So welcome to today's Data Science on AWS Meetup. For those of you who might be new to these sessions, we run those meetups every month, and we always invite very exciting guest speakers to present on very different topics. We do have BMW today, which I'm super excited. And we also do have the Amazon Redshift product team here who will present on Redshift Serverless. So what we're doing each month is inviting guest speakers to present really around topics in the AI/ML space, in the data space. And many of those topics we also discuss in our book that Chris and me wrote. It's called Data Science on AWS, which is available. And we also do have the website here, which Chris can maybe post in the chat, which has a lot of links, not only to the book, but also here to this meetup we're running, to workshop code. If you want to run some sample notebooks, check it out. And also to the YouTube channel here on the top, which you might not see right now, the videos here, which takes you to our YouTube channel with all of the recordings. And today, as I already kind of introduced, we will have, let me just come here to our events page. We have BMW here with Simon, and Simon will give us a sneak peek into their BMW Cloud Data Hub platform. Super exciting what they've built internally. And we will see a live demo of this platform. And then next, we do have Niraja and Naresh from our Amazon Redshift team here at AWS. And they will talk a little bit about all the new and great things that came recently with Amazon Redshift, in particular, also looking a little bit deeper into Amazon Redshift Serverless. And with that, I don't want to steal too much time here and hand it over to Simon, who will start with the BMW Cloud Data Hub session. Simon, welcome to the session today.
Yeah, thank you for having me today. And yeah, we'll start right away. Just let me share my screen and then we can get going. So my presentation is visible, right?
Yes, we can see the Cloud Data Hub starting up.
Perfect. Yeah, so maybe some introductory words to myself. So I'm working at BMW for 6 years now. Yeah, started in a more research and development savvy department, and then I headed over to the central IT department to really build a really advanced data platform that we now know as the Cloud Data Hub at BMW. So how are we going with this presentation today? So we have first the overview, then we're diving right into the demo. After that, we will have a deeper dive into the architecture, and yeah, finally we have a wrap up of the session. So let me dive directly into the overview to give you a little bit of a sneak peek what we have here at BMW and how it looks like. So basically, our goal is at BMW Cloud Data Hub team to make our data that we have in the company universally actionable. And for that, we first need a central point where all of our employees can go to. They can discover the different data sets, they can explore the different data sets and build their explorations or analysis in tools like SageMaker, bring the data from their departments onto the platform, and furthermore, creating value out of all the data that we have at BMW. And this is really the aim of our data portal, which is available for every BMW employee. And there you have all those different features listed here. So you go there, you can discover the different data sets that we have at BMW. You can bring your own data sets if you want. You can create your own use cases where you can build your analyses or visualizations. But you can also build your own provider accounts where you can bring data onto the platform. And of course, we have a strong sense of governance on the platform. So there are different access rights that are attached to your environments that you own. You can request access to different data sets. You can have preview of data sets and all that stuff that we will later see in the live demo. Then how is it architected structurally? So basically what we have there is we've built a central data platform here in the middle with the data portal available under data bmw.cloud, which is only available internally right now, and an API, which is orchestrating all of that in the background. And we have those layers here that we see, where you now see global and market hubs. And these are the different hubs, as we call it. So different data spaces for different markets throughout the world. So there's the global hub, which is run by the BMW headquarters, but there are 20 plus hubs all over the world, where, for example, our dealership organization or our market units can bring their own data in and do their own analyses there. And this is also what you see on the left side, where you have those different accounts from the global IT, for example, where you can bring all the data into the global hub, but you have also the accounts from the local markets where they can bring their own data. And on the right-hand side, you have the use cases where the actual magic is then happening to derive real insights from the data that is stored in the Cloud Data Hub into dashboards, for example, or machine learning models. And there, of course, you can combine the data from different hubs and also from different data sets to gain those insights. So this was really the first preview on what we've built here. And yeah, where are we coming from? Basically, we kicked off the project in 2019. And yeah, within that year, we arrived at 100 terabyte of data stored. And in the next year, we reached our first petabyte of data and also released the data portal, which is basically the overhaul of an earlier web interface that we had, but that was not nearly as nice and yeah, optimized as we have it right now. And at the moment, or over the last year, we arrived at over 4 petabytes and 300 use cases, 5,000 internal users plus. And here on the next slide, you see an overview really of how our platform is structured today. So we are at the 4 petabyte at the moment, and we have our data portal as the central gateway. We have over 3,600 data sets and over 1,500 AWS accounts on our platform. And all of that is backed by our 10 APIs, which are powered by API Gateway and also GraphQL and AppSync. And of course, by all of the services available on the AWS platform. So we are heavily user of serverless services like Lambdas or ECS Fargate, DynamoDB for storing all of the metadata, and OpenSearch, for example, for enabling the search functionality. So I think that was enough of the overview, and now we really dig into our data portal, how it is working at the moment. So now I'm at our data portal here at the integration instance, just because showing you the prod data is not really appropriate, I think, but here you get a good glance on how our data portal is working and the Cloud Data Hub in the background. And first, what is essential really is that you see these different markets here. So as we are on our integration instance, we not have only the Earth, but also Mars here and China for testing the AWS China regions, because as you know, they are always a little bit special, the China partition. So this is a very important selector. And there we have our role switcher. So as I said before, we have a multi-account setup. And here, similar to AWS SSO, you can use that role switcher here to switch between those different AWS accounts or the roles inside of these AWS accounts. But you can also switch, for example, directly onto the AWS console in a separate window, and you can just work on the AWS management console as well, of course, if you'd like that. But getting back to the data portal, what we have here is really the overview. So how many, what's the data volume at the moment? What is the consumption? Because we are here at integration platform, of course, it's not that much that is going on here, but you see also the most popular data sets. And the data set is really the fundamental unit we are dealing with. So this is where all the metadata is stored for a specific amount of data, and a data set in the end is a collection of S3 buckets and a collection of glue databases together with the metadata, as you see here. For example, you can have a description, and you can see here who is responsible for a data set, like data stewards, data engineers, who is contributing. Then you have a little bit more technical metadata, like what's the support level, what is the operations group, what's the ingest frequency, and all that stuff. But also more PII related information, like if it contains PII, or what is the confidentiality level. And then we have also metadata indicators, like what's the query performance. And we are estimating that with the file size, so how many files are in there in those S3 buckets, or what's the size of those files, and therefore how good it will be queried by Athena. And we have also a metadata score, so how much details you filled in here in the metadata. So you see here that we only reached like 50%, and of course there's room for improvement. Then we have our resources here, where you can create file stores or databases, and file store is an S3 bucket in the end, and the database is a glue database. And this is the location where the data is then actually stored. So as you see here, we have here a bucket created for the data set, and we see the bucket ARN. And because I created this bucket with my provider account here, I can store data in that bucket and upload data there and upload the metadata definition. And afterwards, I can also give access to other accounts to this data set. And this is actually what we see here. So we have this consumers tab, where we see that at the moment there are 3 other consumers of this data set, but I could also add other consumers to this data set and for specific environments. And this is something that I can do as an administrator, but it's also possible for other accounts to apply for access. And then I would get a notification to approve this access. And as a next feature, we have also discussions, which are not too relevant here in this example, but these are meant if there are, for example, data quality issues, that the consumers of this data set can directly interact with the creators or providers of this data set, and they can have a discussion about the content of these different data sets. One important tab is also the Lineage, data Lineage tab. And we started with introducing this manually applied lineage here. So basically you can define, this is my upstream data set, and the other ones here are the downstream data sets. But what we've recently introduced is the automatically generated lineage. And there actually the glue jobs themselves write the lineage information. And this is what we see here. So the orange box here is a data set, and the blue box here is the glue job. And this diagram here tells me that the TE execution task table has been created by the TE execution task glue job, and there has been a repartitioning happening from the source system where the data has been read. And of course, this enables a much more fine-grained lineage, because here you see much more details on the repartition operation. What is the input schema? What is the number of partitions that has been written? And what is the output schema? And in the end, when this will be adopted by more of our data providers, it will really enable a very fine-grained lineage throughout the whole process. And what I can also see is the latest job runs. So here I see the job run ID that has been conducted for this glue job when it last run. But if there are more job runs of the same glue job, there will be also a history shown when those jobs have been running. Now switching back to our portal here, we see that in the data catalog, there are not only data sets, but there are also use cases and data providers. And those are those boxes I talked about earlier. So on the left side, we had our data providers, which are responsible for ingesting data. And here you have, similar to the data sets, different metadata, for example, who is owning the provider, you can have different environments, and environments are effectively AWS accounts that are grouped into a provider, because normally you would have like a dev stage, an in stage, and a prod stage for your provider, and therefore you would normally have 3 environments under one provider definition. And we have a very similar structure for use cases. And use cases, as I said, are really the entities where the analysis or visualizations are done at the end, or also the machine learning model building. And this is, a similar concept to the providers, where you can have different environments under one single use case umbrella. And we use those use case and provider structures to really provide a structural or an easy structure for our users to find what they need. For example, for a use case, they can search for similar use cases with our search functionality, and then can request access if they want to, for example. Then looking again at the datasets page, and looking at our example dataset here, you can then have a deeper look into the structure of the data. So first you can have a look at the schema, for example. So here you see a single table, and you can see the name of those columns in the table, and also the type. You can add a description if you want. You can mark it as a primary attribute or a PII sensitive attribute, but you can also have a look at the actual data in the background. And this is powered by Athena. And here you see a data sample of the first 10 rows, but you can also open this data set in SQLab. And then you can basically use the normal SQL functionality to dive into the data and do like a first exploratory analysis. And this functionality is available for data that I have access to, because I have read access or write access, but it's also available for data that I don't have access to. And this is what we call the preview functionality. So you have access for the first 100 rows of the data if it is not containing PII information. And on this way, you can do a little exploratory analysis of the data. And when you are confident that you really can gain insights from the data, you can do an access request and then have access to the full data. Then when we look at the left side here, we have 3 tabs missing. So the data ingest tab is really for creating easy data ingests right from the data portal. And here we see that actually that iris flower dataset that I've shown you before is done via this data ingest tab. And there we see the job status, when it has been running the last time, the execution time, where it is coming from. So here we have a Postgres database with an AWS URL. And we have configured which tables we want to ingest and all those different options. And this is really an easy way to bring your data onto the Cloud Data Hub without, I don't know, knowing Terraform or knowing, or even going to the AWS Glue console, because what happens at the end is a CDK stack is generated out of the information that you're adding here, and it is deployed inside the account that you selected here in the role switcher via CloudFormation without you knowing even about those technicalities. And something similar we have for the data analysis side, where we enable you to create those data analysis stacks. And here you can configure your environment. Either you can spin up a single SageMaker notebook, or you can spin up SageMaker plus EMR cluster. And here you have very, very easy means to configure what kind of cluster do you want to have. So I don't know, I want 30 instances of instance type M5X large, and then everything gets set up in Bootstrap for you. And when it's running through, you just have this Open Jupyter Lab button, and then you're ready to go, and you don't even need to go to the EMR console. And for the last tab here, we have the deployments tab. And this is basically an easy way for you to deploy infrastructure in your own account, similar to the data ingest and the data analysis tab, but it's a little bit more general purpose. Let's say, for example, you have those presets here to run an Aurora cluster or to run a machine learning pipeline inside your account. And this is something where we want to enable our users a little bit more to share their own templates and have a marketplace of infrastructure that you can spin up via the data portal. So I hope this gave you a first glance on what the data portal and the CDH is doing. And now we get a little bit more into the architecture. So first, maybe some words to the metadata model. Basically, this is what I've shown you in the portal interactively. We have those business objects, for example, vehicle or finance, or all those big business processes that we have at BMW. And those business objects are the main entity, and data sets are assigned to those business objects to have some logical grouping. And data sets can be grouped into different layers. So we are using the source, prepared, and semantic layers, and those are only providing you guidance on what is the maturity level of that data set. For example, the source data set is really raw from the database, prepared is a little bit technically cleaned, and semantic is far away from the original storage and more oriented for the analytics purposes. And in addition to that, of course, we store some metadata, and we have also the hubs in the background, which are the tenants on our platform. When looking deeper onto the architecture of the platform, we have those 5 fundamental building blocks. So we have the data portal, which is separated in its own account. And there we have GraphQL API as the central point to talk to our React app. And this GraphQL API is backed by the search, which is powered by OpenSearch, but also by various Lambda functions and by DynamoDB tables, which are holding metadata and supporting those processes like the access requests and all those functionalities you see in the portal. And in turn, this GraphQL API is also building on the CDH API, which is shown here in the right account. And that API is orchestrating all the fundamental AWS services for handling data sets and handling the provider and use case accounts. And it stores also its own data in a DynamoDB table. And when you create a bucket for a data set, it actually goes into a resource account, as we call it, where all the data is stored in S3 and all the Glue metadata catalogs are living and creating the S3 bucket inside of this resource account. A resource account is always part of a hub. In this illustration here, it's part of the global hub. And on the left side, you have always the provider account that is writing onto the S3 bucket. And there's only ever one provider account for each S3 bucket. And on the right-hand side, you have the use cases where you have your analysis jobs, for example, on Glue. And those accounts are typically reading from S3 and reading from the Glue data catalog to get the metadata and to work with the data. So zooming in a little bit more on the provider. And there we typically have those data ingests, as I shown you in the portal. You can either create that via the data portal with the CDK stack, but we have also Terraform modules for doing that. And basically, it looks very similar to this diagram here, where you have a Glue ETL job, which is triggered by a Glue trigger. And this Glue ETL job is reading from databases which are either hosted on-prem or are hosted in other AWS accounts. It uses that data, sticks it into the S3 source bucket, and also writes the metadata of the ingested data into a Glue data catalog. So you can have easy access via Athena or Glue ETL and have always the metadata to the actual data on S3. It of course uses all those auxiliary services like CloudWatch or the Secrets Manager to handle the data. Then on the use case side, we have something called code workbooks, and this is basically a template which makes easier to develop those data transformations. And we are using our on-premise Bitbucket to store the source code of the transformation pipeline, and then we spin up via CDK and CloudFormation 3 pipelines. So for one, we have the exploration pipeline, which is shown here at the bottom, where you can interactively create the transformation code in a SageMaker notebook and test it out via the Glue development endpoint. Then we have the development pipeline, which is shown here in the middle, where you can test the code on a dev instance, on a development bucket, and transform your code on pull requests. So every time you make a pull request, you can have a look at the actual data, how it would be turning out on pod. And when you are confident, you can merge your code, or you can merge the pull request in Bitbucket, and then the production pipeline is running with the code of your newly merged pull request with all the data in production. And this is something we are introducing at the moment to make it easier for our customers to write data transformation pipelines. Yeah, I think these are the really fundamental building blocks. So either on the platform side, on the provider and the use case side. And basically for Wrapup, what I want to give you on the way is that it is really important to build a community around your data platform. I mean, this is what we've seen with our Cloud Data Hub. We are basically only providing the basic building blocks, and we are not doing the actual data ingests, but we are working together with our data providers, either in the central IT department or with the markets, to bring data on the Cloud Data Hub. Because of course, a platform without any content on it is just not worth it. And on the other hand side, we are also working with our use cases on, for example, refining our code workbooks, or finding out what kind of support they need, so that we from platform side can build a strong offering for them, so that you don't have to reinvent the wheel every time you're building a use case. Then as a second point, we use managed services to focus on user value. Basically, what you've seen in our architecture diagrams is that we are only ever using AWS managed services, or very, very high level services like Glue ETL, Lambda, SNS, SQS, and all those services, which makes your life easier as a developer. And this is really something what we love about AWS, because you don't have to work with raw EC2 instances if you don't want to. I mean, you have always the possibility, but we find it much more valuable to concentrate on our business value and not work only on the infrastructure level. And last but not least, evolve your platform to address changing service and customer needs. So we've seen that for services with AWS Lake Formation, which we are introducing at the moment. So we all constantly adapt our offering when AWS brings out new features, and we want to integrate that, of course, because it removes also development pressure from us if AWS enables a new service which just can do a feature out of the box, which we would have to develop ourselves. And of course, our customers have always new ideas what they want to have as a platform service. And for us, it's really about focusing on the right stuff to build, because of course our customers have a lot of ideas, but we have to see what really makes sense from a platform perspective, and then we are really eager to build it and build it with a good user experience. And maybe one last word. We are currently in the process of open sourcing all of that we've seen in the demo and here in the presentation. And we are working really hard on that. And our goal is to do it over the next 1 or 2 months. So stay tuned. And then you can try it out yourself, hopefully soon. Then thank you very much for listening.
Yeah, thanks so much, Simon. That's great. I'm still impressed by all the goodness there that you built in this platform. And I also love the marketplace idea, right? That you're encouraging team members, other teams to actually contribute their workflows if they want to integrate in a way. That's kind of really exciting.
Yeah.
Yeah, we do have a couple of questions that came in here. Let me check. So on the one slide where you're discussing the architecture, we've seen Java code on the screen. Question coming in, what about Scala? Is it possible to run Scala notebooks as well, or pipelines?
Yeah, sure. So we are very agnostic. Basically, with our modules that we have, for example, in Terraform, we are kind of guiding you into the Python direction, but there is nothing preventing you from running Java or Scala in there. And basically, we support what Glue ETL is supporting.
All right. And then there was a question around the Cloud Data Hub API. If you can maybe give a little bit more background on that. Is it a REST Rep API?
Yeah, so this is basically a REST API that we've built with Python. So maybe I should have said that most of our stuff here is written in Python that we do here. And this API is doing really the orchestration. So creating S3 buckets, registering accounts, creating accounts. So really the low level stuff to be enabled on AWS. And the data portal and GraphQL API is really more about the user workflows. So for example, requesting access and not so much about creating AWS resources. So this is the separation between those two.
Okay, any Dask usage?
I think some of our customers in the use cases are using that. But we, from a platform perspective, have no module for that at the moment.
All right. Just checking here the chat. There's a couple of questions. Not sure if you can comment on that. Feel free to say if not, but how big is your team and which profiles are involved in the development? Yeah, so maybe what I can say is that we basically have four big teams. So two on the front end side, one for the CDH API, and one that is more focused around authorization, authentication. Yeah, about the size, well, hard to tell or hard to say. But what was the second question again? Yeah, the profiles involved, I guess, yeah. And maybe the person can clarify here on the chat if it's like I think job profiles. Yeah, so personas, actually a good question. So yeah, we are working heavily with UX experts for the data portal. I think that this is something that you can see easily that I don't know, a backend developer did not invent those flows, but there is really a lot of thought in those flows. And of course, we have a lot of DevOps folks in the CDH API topic, but for the front end, I would say that most of them are really full stack. So doing the front end stuff, but also doing the lambdas. And of course, we are hiring. So visit our job site at BMW. Perfect. Yeah, Chris, any more questions? You're keeping an eye here on the chat too that we should address?
Yeah, thanks again, Simone. You know, a general thank you for being so transparent, because I know you guys have done this for Reinvent. You know, the last couple of years, we've seen the evolution. Very excited about the open source. Yes, I know that's a very, very difficult thing to do and to, you know, separate the proprietary code from what can be open source. I have gone through that back at Netflix a couple of times. And it's not an easy task and can oftentimes get sort of, you know, down prioritized. So really excited to see that. I think a lot of people can benefit. Someone did ask, you know, who really benefits from this going open source, and because this is using quite a lot of AWS services. So obviously AWS customers. I could see this being used by a lot of startups. I work with a lot of startups, you know, throughout the week as part of my role. And I'd say 80% of the time I say, oh, just wait till, you know, BMW open sources this. It's going to totally help you out. So, but I guess there's maybe an implied question here of, or, you know, can this be used with other clouds? Can you plug in? Is there some way to plug in?
Yeah. So one thing that is quite tied to the AWS setting in general is, of course, the CH API, which is all the orchestration. But the data portal itself is very agnostic, I would say, in a way. So we don't have any plans like to build it for Google or for Azure again or whatever, because we really love the AWS environment that we have at the moment. And but I think when we are open source, we are really open also for other contributions. I would say it's really our plan. So why are we doing that? So for one, we've built something here that other people can benefit from. But of course, we would really love to see contributions also from other people and companies who want to really improve on that data sharing, data platform story, because I think there is a lot of open space at the moment to really build something great there.
Yes, one last question, at least from my standpoint. Are there any contributions you would be looking for in the near term? Yes, I realize it's not open source just yet, but once it does drop, is there anything you would love for the community to potentially tackle?
I think one thing where we have an open spot at the moment is in the way of machine learning pipelines or better integration of maybe business users, I would say. So those topics are a little bit open at the moment, or not as good as other parts of our platform. And of course, we are trying to improve there, but as you know, there are always ideas and other features that you have to prioritize first. So yeah, I would say these two topics.
So would that be like the SQL Lab tab that I saw on the demo?
Yeah.
Okay, gotcha. And then the other one, I remember seeing like an ML ops for the marketplace type thing. So, okay. So yeah, that's where they were plugging there. Okay, great. Yeah, Antje, any other questions from?
We do have a question, and Simon, you might want to take this one-on-one here in the chat for folks actually joining and listening in here from BMW Group, how they can internally reach out to you.
Okay, yeah,
so you
perfect.
might want to tackle that one-to-one. And then one last question: any transformation from unstructured data to a structured format in the data pipeline?
Yeah, I think there we have also some open points, because most of the time, to be honest, the data that we are ingesting is coming from relational databases. So it is most of the time already structured. But the good thing is, I think about our modules is that they are really, really open for modification. Basically, if you somehow manage to write that code inside of Glue ETL, either be it Python or Java, Scala, then you will be able to use our modules to bring it into the Cloud Data Hub.
Which then ties into your Lineage and all that, right?
Yeah.
Perfect. Yeah, that's awesome. Yeah, great, Simone. Yeah, great seeing you again.
Perfect. Thanks so much, Simon. Really appreciate your time today in presenting this. Absolutely.
You're welcome.
All right. And with that, we'll switch over. And I'm introducing Naresh and Niracha from the Amazon Redshift product team. And they will give us a glimpse into all the great new stuff that Amazon Redshift delivers, and specifically a look into Redshift Serverless, right? Take it away, Naresh and Niracha.
Absolutely. Hello, everyone. This is Naresh Chenani. I'm an engineering director at Redshift. And Nirja and I are here to talk about Redshift Serverless. Nirja, do you want to intro yourself?
Unmute. Hi, everyone. This is Nirja Renchintala. I lead the product management for Amazon Redshift.
All right. Thank you, Nirja. Let me get my screen sharing going. Can someone confirm if they can see my screen?
Yes, we can see. If you want to flip into presentation mode. Yeah, perfect.
All right. Hey, thanks for joining, guys. So today we are going to talk about Redshift Serverless. And before we get into the details on the architecture and the thinking behind serverless, I would like to talk to you about what where Redshift is currently today in production with provisioned instances, and what led us down this journey towards a serverless Redshift. Nirja will then follow it up with a demo on take a walk through a scenario, in which case when serverless can be very useful. So with that, let's jump right into things. Okay, so first of all, why do customers pick Redshift, right? So it's really Redshift's main biggest advantage is you can analyze any data with very good price performance. This is what we hear from customers who want to get insights in seconds or minutes. Redshift powers dashboards with high, very demanding SLAs. And Redshift gives you all the control you need in terms of price and performance. So you can, for example, pick up which instance types, how much scaling you want to see. And this is really a balance between your SLA around performance as well as around cost. So here's a brief look at what the Redshift architecture is today. So what we have is we have applications that are connecting over, say, JDBC or ODBC or data API that we introduced about 18 months ago. And what you see is a Redshift cluster. So there's a leader node and a set of compute nodes, which are serving and responding to any requests. So this is at launch. This is what Redshift looked like. This was back in 2013, almost 9 years ago. Then in a few years later, we introduced a way for Redshift to be a data lake platform. So where it can query not just its own Redshift data, but it can also query open file formats. And this would be data on S3, which includes Parquet, JSON, ORC, Avro, and all the various file formats. What Spectrum provides is a multi-tenant, massive scale-out fleet. So now imagine if you're querying petabytes or even exabytes of data, the Spectrum fleet can scale out to serve these queries. It's a very fast scanning and aggregation engine. Followed by Spectrum, what we heard from our customers is concurrency of Redshift is quite limited. And the use cases around this we started seeing is dashboards that are being refreshed by hundreds of users. And the single cluster is not sufficient. And what customers would request is like, hey, is there a way to reduce the queuing and increase the concurrency of the system? At that point, we introduced concurrency scaling in 2019. And what happens with concurrency scaling is Redshift now auto scales. As work starts arriving at Redshift and the primary compute is getting fully utilized, Redshift starts auto scaling. So there are these transient compute clusters that are provisioned, and they serve the peak demand and then are deprovisioned after the demand subsides. In 2019, we took a big step towards separating compute and storage. So this was when we introduced Redshift Managed Storage. This is where all the Redshift data would be stored on RMS, that's Redshift Managed Storage. And the compute clusters became stateless, so they did not have any persistent state. They would read from RMS and serve queries. So basically the compute was a cache of data, cache of hot data. We also introduced Aqua as an hardware acceleration platform. It would take any complex operations, like say, for example, regular expressions, and use FPGA techniques to accelerate them. So one of Redshift's strengths, which I talked about performance, the reason Redshift has really good performance is it compiles code. So what Redshift does is generate C code, which is compiled and then executes. which is great for execution performance, but it does introduce an overhead when it comes to compilation. To alleviate that, what we introduced is a compilation as a service, which is a fully transparent mechanism to scale out any compilations on Redshift. So that's already been out and deployed in all regions. Finally, last year, we introduced data sharing. And the idea behind data sharing is large enterprises, there are different teams that are operating on a single source of truth, shared data. However, they all want their own compute, and this basically goes back to chargeability. They control when the compute, how big it is, and what their performance requirements are. So data sharing provides users with compute isolation. So for example, marketing can have their own compute, and finance can have their own compute based on month-end processing and whatnot. And they are all both operating on the same set of data. Data sharing has been immensely popular with our customers. We started with sharing across clusters within the same account. This evolved to sharing across accounts. And just a few months ago, we released sharing across regions. So you can be in 2 different AWS regions, and your Redshift cluster in region 1 can query data in a transactionally consistent manner from region 2. That's another thing our customers are actually quite excited about. So in terms of performance, one thing that I like to say is like the best way to improve performance is to avoid repeat work. To that end, we introduce materialized views, which are able to basically serve your dashboards in a high performance, consistent, short query SLAs. And what Redshift does is automatically maintain the materialized views as the underlying data changes, and also matches. So when you're querying the base tables, Redshift's rewriter and planner automatically detect if it is a good idea for this query to be served from a materialized view, and then makes it happen. Last but not the least is Redshift machine learning. What we realized is with so many different AWS services, we believe in purpose-built services that really do things well. So we had Amazon SageMaker, which had an immense knowledge base of models and training. What Redshift did is integrates with SageMaker, and the training happens via SageMaker. However, the inference of the model is actually pushed down into Redshift compute. So the inference happens inside Redshift's compute clusters, close to where the data is. And this really gives you the best of both worlds. You get all the advances that SageMaker is making with respect to training models, the performance, the getting information on bias detection, and so on, while the inference is executing on in an MPP manner on the Redshift compute nodes. So with that architecture I described, Redshift customers had a lot of flexibility to pick what is the performance needs. For example, they would pick either RA3 or DC2. They would pick number of nodes. We offered options like manual workload management or automated workload management, introducing query priorities, ways to scale up and scale out. And finally, also a way to pause and resume clusters so that you're only paying for compute when you're using it. All of this flexibility was great. However, there was one thing that we repeatedly heard from customers. And this was a lot of the business users, they don't really want to focus on the infrastructure side of the data warehouse. What they want is they want to worry about their problems, getting insights out of the data, rather than having to figure out when the compute can be paused or how to get the best performance, how to tune the workload manager. And the second reality that we saw is workloads are not steady state. So what we see is over a course of time, even during the day or during there are daytime, nighttime patterns, there is scaling. So workloads tend to be inherently unpredictable. Also ad hoc workloads, you really don't know what your users are going to do. And this is what we see in an increasing just use cases around these. So what we wanted to do is we wanted to combine the performance, the SQL capabilities, and the scalability of Redshift into a very easy to use package where a user doesn't have to make a lot of decisions in order to get started and start getting those insights. To serve these use cases, what we launched is Redshift Serverless. This was announced in public preview at last reInvent in 2021. And what it provides is a simplified user experience, and you're going to see a demo shortly on that. You get all the Redshift performance, the architecture that I described. All of this is behind the scenes of Redshift Serverless, without you having to explicitly enable when to scale, what to scale, should I pause my compute. So a lot of work has gone into the compute side of things. I mean, really, that's what serverless is. It's a compute platform that can scale automatically to serve your workloads. And finally, you only pay for serverless when you're using it. So basically, the pricing model for serverless is you are paying for compute capacity, and it's basically at a second granularity. And if a compute is not running any user workload, you don't get charged for it. Okay, so diving a little deep into Redshift Serverless. You will notice this picture looks somewhat similar to what we just built up before. You still have compute isolation through data sharing. You still have Redshift managed storage. You still have the ability to query open file formats, Parquet, etc. And you have all the strong integration through SageMaker and the performance via materialized view. So what has changed? With Redshift Serverless, Redshift basically automatically scales. What we have built is machine learning based workload monitoring, which would look at multiple things. One is around queries, the resource management. What at Amazon, what we strongly believe in is using the compute very wisely, because you're already paying for those resources. So this is where having a smart and effective workload manager to maximize the utilization from the compute is important. Once you fully utilize it, beyond that, Redshift Serverless will automatically scale. It also will, as some of you may be aware, there are a bunch of tuning and maintenance tasks that are needed for databases to perform the best. We have fully automated those. What this means is data distribution, data clustering, sorting data, or collecting statistics. All of this is fully automated, and this happens behind the scenes, and this gives you the superior price performance without having to invest in either cluster management or database management. So really, the onus here shifts back to the application developer or the analyst to just write queries, get the best value out of the data, and build applications. In terms of billing, what we have is there is a billing for compute and storage. Storage has a fixed, it's a gigabyte monthly rate, and then you can restore. We have something called restore points, where you can restore from any point in the last 24 hours. And there are some granularities, which is a 30-minute right now. On the compute, which is where a lot of innovation has happened as part of serverless, we introduced the notion of Redshift Processing Unit, RPUs. And it's think of it as an abstraction of vCPUs and memory. And the way a customer is built is in terms of RPU hours, and the metering happens on a per second basis. So if for example, if you're running a workload for 35 seconds, you're billed for those 35 seconds only. Secondly, the RPUs are the same means for any kind of scaling decisions that Redshift Serverless makes. In the past, for some existing users of Redshift, you would see a separate charge for features like, say, concurrency scaling for the additional compute, or data scan charges for spectrum queries. And all of these are no longer explicit charges in serverless. Here's an example, really, for you're paying for compute only for the duration you're using it for. So this first, like if you look at queries 1, 2, and 3, the one point to make here is they are running in an overlapping fashion. So like query 1 is executing, and query 2 and query 3 are running on that same serverless compute. As a result, what you're paying for is this duration, you're not paying for each of these queries, which can be advantageous when you're running concurrent queries. And again, you're not paying for any compute when there are no user queries running. What Redshift Serverless does is there is some idleness smarts built into the system, but that's really up to us as a managed service to provide the best experience for our customers. Okay, so I talked a lot about making things easy to use, right? So our vision with Redshift Serverless is zero touch. So you basically just get started. And again, Nirja will walk you through it in just a few minutes here. We do provide a couple of optional controls. One is around performance, and second is around cost. Like think of it as a budget control. So that way there are no surprises of any kind. So we have this notion of base compute, which is base RPUs, Redshift processing units. And you can what this helps you do is, so we start somewhere, right? And if you want more performance, you can basically increase the number of RPUs. If you want to lower cost and you're very happy with the performance you're seeing, you can actually reduce the number of RPUs. So this is one control. And the second is, think of it as a usage limit, where you can say, hey, I don't want to use more than 10,000 RPUs in a month. That gives you a predictability around what the costs are going to look like. And then you can also set certain actions around these usage limits. For example, you can say just log, alert me, or stop usage. And you can have multiple of such thresholds, different tiers, basically. Is there a need for migration from, say, let's say if you're an existing Redshift provision customer, how do you get started? It's actually very, very easy to get started. Your applications don't need to change because we maintain SQL compatibility, the authentication, access control. You get all the value out of Redshift that you're getting today now in a much easier to use, pay based on what you use kind of package. We briefly covered this, but just real quick. So why would you use serverless? You get the advantage of easy analytics. You no longer worry about cluster management with serverless. You may also want to consider serverless if your workloads exhibit high variability, ad hoc workloads or peaks that you see. And we like there are patterns, like there might be periodicity where at 9 a.m. where everybody logs on, and that's when you want to benefit from instant scale out without having to worry about it doing it manually. This would be another use case for serverless. We have been in preview for roughly 4 months, a little less, and we have over 3,000 customers that are actually using this in preview, giving us very valuable feedback. I would highly encourage folks here to give it a try. It is, again, very easy to get started. Here are a couple of comments from customers where some like simplicity, others loved the performance, the price performance that the solution gave them. And it's really around us emerging towards self-service analytics use cases, and serverless is a key tool towards that. With that, we'll go into the demo, and then after that, we'll take some questions. Nirja?
Yep. Thanks, Naresh. So I will walk through a very quick demo of Redshift Serverless. So the demo scenario is it's just pretty simple. Basically, I'm a data analyst. Let's say I'm a data analyst at the marketing department of a large US apparel company, and we have both online and retail presence. And we are a few weeks away from the end of the quarter, and we are below 20% or so in terms of our revenue target. So to give a boost to our business, the marketing department is tasked to come up with a promotion, right? So the promotion, the idea is basically to improve our sales, and I'm doing the analysis to provide this recommendation. And I want to use Redshift Serverless because I don't have to worry about infrastructure management, data warehouse management, and I can just focus on coming up with an effective promotion. So in terms of data sources, we have data spread across multiple data sources. So one is Amazon S3 Data Lake, which has historical sales information, survey data, promotion data. We have our real-time information in the sales information in operational databases. The main one is RDS Postgres. This is where we have the real-time sales order data as well as our inventory. And in Amazon Redshift, which is our data warehouse, we have the 3-year sales information, and this is updated on a daily basis. So my goal is to use all these different data sources and come up with a good recommendation that for our upcoming promotion. And can you go to the next slide? Yep. So as Naresh mentioned, getting started with Redshift Serverless is very easy. You just go to AWS Management Console, Redshift, and you can say, try Amazon Redshift Serverless. So you get to, when you set up the serverless endpoint, you can choose the default settings. So that's so that you don't have to worry about changing anything. But if you have specific security policies for your company, you can choose things like VPC, subnet. You can specify your own encryption key, and you can also optionally enable audit logging. So really, if there are very specific settings for your company, otherwise you don't have to worry about setting anything. And in this case, I'm going to access data from S3 Data Lake. So we are just configuring an IAM role. So that's it, right? So you go ahead and start creating a serverless endpoint. So note, I didn't have to choose any node types like an instance type, specify node count, or do any other compute related configuration. So once I set up the endpoint, I go to the query editor. So query editor is the out of box query interface for Redshift. And here I can connect to our Redshift serverless database, just specify the username, and I want to provide credentials on the fly. And and connect to the serverless. So in query editor, the good thing is I have a bunch of sample data sets, so I can kickstart analytics with Redshift. This includes benchmarking data sets like TPCH, TPCDS, and other interesting data sets. So I can also create database schemas and tables. So let's explore kind of the data that we want to look at. So in Amazon S3, as I mentioned, we have historical sales information, so for 2017 and 2018. And this data is in an open file format called QuickSight, Parquet. And the operational databases has information on the real-time sales orders. So we are just trying to see if this is the right data that we want to query from Redshift. So we are doing this from RDS Postgres. So once we do that, yeah. So the operational databases again has the information, as I mentioned, on the sales data and the inventory. So we are going to take a quick look at it and ensure that this is the right data that we want to query. And in Amazon Redshift, for simplicity, we already have loaded the data. So this has the 3-year sales data. So one nice thing with the query editor is, as you can see on the left side navigation, I can actually navigate all this data. So the data warehouse data that I have loaded into Redshift, and also the data from the S3 data lake, as well as the data from the operational data sources. So we can do a couple of queries for the data on the data warehouse. You can actually visualize in charts. You can collaborate with your teams. Query editor is a very nice, convenient tool. On the RDS, the sales.rds, which represents our operational database, Redshift allows you to query that with the federated query capability in place without having to copy the data into Redshift. Similarly, the data lake data, we can query it with high performance in place. Again, no need to copy it into the data warehouse. So what I want to do is basically I have my data in the data warehouse, operational database, and data lake. So I want to combine it and create a unified view across all these data sources so that I can do all my analysis using this combined view. So I'm doing this view, combining all this information. So once the data is set up, I'm going to just do a couple of quick analysis here. So I'm trying to see how is the sales trend in the past few years. So I see that compared to the last couple of years, there is a decline in sales. So I want to see which specific categories are contributing to this decline. So we are going to go category by category and see where the decline is. And I see that mainly in women's and men's category, there is some specific level of decline, which I want to deep dive and understand to see if we can target our promotion around that. So what you would see is I also want to figure out what kind of promotion that I want to offer. So we have the marketing team has stored the previous year's promotion data in S3 as a file. And this data has been curated by removing some specific anomalies that are very specific to those previous years. So the query editor offers a very nice interface to bring the data into Redshift so that I don't have to write like SQL commands. So I can just choose this specific promotions file in S3. I can say what permission I want to use. I can specify which schema and which table I want to load this data. And like just in a complete UI format, I can easily bring the data into the data warehouse. And now I'm switching the analysis to QuickSight, which is a business intelligence service in AWS Stack, to kind of dive into the analysis in a little bit visual way. So once we go into the women's category, I'm trying to see which specific subcategories are contributing to the decline. And I see that the dresses subcategory is showing some decline. And similarly, I'm going to kind of see in the subcategories in the men's category as well. And I see the pants category again is showing some decline. And if I look into the promotions, typically our 20% promotions seem to be doing the best. So my recommendation would be basically offer a 20% discount for these specific subcategories. So if you think about it, many analysts like me, right, are doing this kind of ad hoc analysis throughout our company, hundreds and thousands of analysts, and the capacity management is a tough problem for us. So with Redshift Serverless, it automatically provisions source resources, automatically scales them, as you can see in this particular graph here. And to dive into things a little bit, this is an example kind of a graph over time, where the orange represents the compute capacity and the blue represents query count, and the capacity is scaling according to our demands. And when there is no workload, there is no capacity allocated, allowing us to just pay for what we use. So as Naresh showed, the base data warehouse capacity, we automatically provision and we scale, but if you really want to control the price performance, you can adjust that. And similarly, you can set up cost controls like on a daily, weekly, monthly basis so that you can keep the costs with serverless more predictable. So one very popular thing I would say is serverless works nicely in conjunction with data sharing. So in this example, we want to share our latest sales data, not the dollar amount, but the sales quantities with our vendors so that they can streamline their supply chain management and do better forecasting for inventory. So I can do that with data sharing. So here I'm creating a view with the sales quantities, not again like the money involved, so that I can share with my inventory, the supply chain partners. So create a data share, I add the specific view that I want to share with them, and I specify the account of the vendor to whom I want to share. So Redshift cross-account data sharing allows me to do that. And on the vendor side, now I'm logging in as a vendor here. I can come in, I can create a database from the data share that I have provided. And this vendor basically can simply just as if the data is local, they're able to do directly queries on the live transactionally consistent data. So essentially you can share data from serverless to provision clusters. You can share between serverless endpoints. You can also share from provision to serverless. And the idea is you're able to create this kind of data mesh type of architectures where you're able to seamlessly share data within the organization, but also across the organizations. So this is a very, very quick kind of overview into how Redshift Serverless, how do you get started with it, and can do like an ad hoc analysis like what we illustrated in this scenario. So with that, next slide. Naresh, can we go to the wrap up slide? Yeah. So just want to kind of wrap up here. So what we are saying is with serverless, essentially you can gain insights from all data. You don't have to worry about creating and managing data warehouses. You just pay for what you use. And the beauty is you can benefit from the simplicity of serverless without having to make any changes to your existing analytics applications that you are running on Redshift. And we see that serverless and provision clusters do coexist. So they both of them complement each other. You will continue to use provision clusters for more fine-grained customization and control that you want when you want over capacity to optimize cost and performance, and serverless you would use for easy analytics and where your workloads are very dynamic and variable. And both these systems can interoperate using the data sharing capabilities. Hope that gives kind of an overview of serverless. With that, we can take some questions if there are any.
Yes, thanks so much, Naresh and Niracha. Really appreciate the presentation and the demo. We do have questions here. Let me read out a few, and I think, Chris, you also kept track here, and thanks for reposting those. What are the SLAs to update data in Redshift Serverless, specifically around volume and latency?
Naresh, you want to take that?
Sorry, I was trying to find my unmute button. Yeah, so the question around SLA is, so basically Redshift is a columnar database, and if you're ingesting data in batches, you can ingest several, like tens of gigabytes per second, just out of the box with serverless. And this can actually, with automatic scaling, you can get to hundreds of gigabytes per second as well. So you get all of this out of the box. What could potentially constrain this is if you have a usage limit set very low, that will force serverless to kind of scale down and not use as much compute. So it's really in terms of throughput. In terms of latencies, there is actually an interesting feature in preview, which is streaming ingestion. So what we support is, if you have Kinesis streaming, you can directly through SQL ingest data from a Kinesis shard into Redshift. And this gives you latencies of single-digit seconds. This is currently in public preview. So again, another thing that you can try. With the combination, you can get hundreds of gigabytes per second and a low latency for your applications.
All right, and a quick follow-up on this one. Is there any limit on data load? Can we use Redshift Serverless with petabytes tables?
Absolutely, yes. There are no limits you can work with very large tables. In fact, in preview, we have customers who have so far tested the terabyte scale, but there will always be a first time for a petabyte scale.
Yeah, I think one key point is Redshift Serverless is also the storage side is Redshift Managed Storage, right, which can support tens of petabytes of data. So that particular aspect is common across provisioned and Redshift clusters. So you can store petabytes of data or query exabytes of data if you want from the data lake.
Great. And how do folks sign up for the preview? Is there any sign up requirement, or how can they test serverless?
Yeah, so this is in public preview. So you can just go to Redshift console. There is a try Amazon Redshift Serverless button. So you just click on that and create endpoint. There is no sign up needed. You can enable serverless for your account pretty quickly from the console.
Nice. Another question on the integration. So we saw QuickSight in one of the screenshots there. Can you share other AWS services that support Redshift Serverless? For example, does Tableau support as well? Serverless Redshift?
Yeah, so all the AWS services that works with Redshift provision clusters. So this includes QuickSight. We can like Kinesis, loading, querying data from RDS and Aurora Postgres. So all the integrations, SageMaker, so all the AWS services integrations, which is actually a pretty good differentiation for Redshift. They all continue to work with serverless. And Tableau, so Redshift Serverless has a JDBC, ODBC endpoint. So any BI tools, Tableau, MicroStrategy, ClickView, so all of them continue to work with Redshift, just like they were working with Redshift provision clusters.
Perfect. A question around the connectors. Is there any connector to Apache Pinot for stream processing and materialized views?
No, we don't have that at the moment.
Okay, so yeah, if you have a good use case there, feel free to share it with us. That always helps in understanding how you would use that connector. All right, and Chris shared the link here to Pinot from Apache. Any more questions? Feel free to put them here in the chat. And Chris, I know you also kept an eye on here. If you have anything else that you saw coming through.
Yeah, I think that's it.
I see a question here on, I can get an external customer to pay for data share queries with their own account. Yeah, so this is what we demonstrated in kind of the data sharing, right? So with Redshift data sharing, you can share data with an external organization, external entity, your own customer, your own partner, and in a live and transactionally consistent fashion. And that particular customer could come in and directly query the data within Redshift? So the answer is yes. So they can come in. And the way the chargeability works is the vendor or the customer that you're trying to share the data with, they come in from their own Redshift cluster or a serverless endpoint. So they pay for their own compute, but the data is shared by you. So you would pay for the storage. So that's kind of how the data sharing, the deployment model works.
Yeah, in fact, that's a very popular usage option, the hub and spoke, where the hub is a provisioned Redshift carefully curated data source. And then you have different business units who are using serverless compute to easily consume the data and paying for what they use.
For the cross-region sharing, are there extra costs associated with the data leaving a region? I know that question comes up a lot when we talk about cross-region.
Yeah, you're right. So within a region, there is no cost to explicitly share the data. But with the cross-region data sharing, because the customer or the consumer would be querying from a different region, there is a data transfer charge to move the data from source to target region. It depends on how much data is queried by that specific query. But the good thing is Redshift also caches the data in the managed storage on the consumer side. So once the query came for a particular data set, and then there are repetitive queries coming in, there is a high probability that that data set is already there in the consumer cluster. But yes, there is a data transfer charge for cross-region.
One final question from my standpoint, and actually somebody else asked it, I think, earlier. With all these cool features of Redshift and Redshift Spectrum being able to query S3, why do we need Athena? So, where does Athena fit in here?
Yeah, so I mean, the way to think about it is Redshift is a data warehouse, right? So it is optimized for high performance analytic applications, the business intelligence application, different types of analytics applications. And a lot of use cases for Redshift revolve around this complex analytics. But more and more with the data also residing in the data lake, the use cases are expanding to not just query the data in the data lake, but also data warehouse, but also combine it with the data from the data lake or from the operation data sources. So typically you have data in these multiple sources and you're along with your data warehouse and you're trying to bring all of them together. So that's one way to think about it. And when it comes to Athena, typically it is for data exploration and ad hoc query type of use cases on top of S3, right? So that's not very well optimized when it comes to the data warehousing type of analytics. So it really depends on the type of analytics use cases that you're trying to do, based on which you can pick the right tool for the job.
Great. I think that's it, Antje. Any other questions? Let's see. Oh yeah, did you want to mention next month? Mm-hmm.
Yeah, I think that's it for today. So thanks everyone for sticking around, and thanks to Naresh and Racha for this great presentation and demo. Just a quick plug, all of the recordings are shared in our YouTube channel, so check that out if you want to rewatch some of the parts, or if you want to check out other sessions that we posted there. And also a quick reminder, next month, April 18 webinar, we will talk about how to use the open source Delta Lake and DBT in machine learning and data pipelines. So super exciting. We do have speakers from AWS and from DBT who will talk us and demo us through that. So thanks again, and hopefully see you next time around.
Thank you.
Thanks everyone.
Bye.
Thank you. Bye-bye.